Okay, good morning again. We are doing the second part of this particular video, and this is video 9.2, nth roots, and we're going to start here with example 4. I actually started this, but we were in the middle of the page, so I'm just going to start from the top. All right, so we're going to express in simplest radical form. Okay, and if you remember, radical has a radical sign. So remember, that's what radical is all about, and we're going to simplify it. All right. So here we have a number with a fractional exponent, and you remember that the power is always the numerator, and the index is always the denominator. So this is really, or should be written as the cube root of 4 to the 4th. Now, you've got to simplify these. So really, 4 to the 4th is 4 times 4 times 4 times 4. And we can take out 3 of those. So let's rewrite this to ultimately simplify it into the cube root of 4 times 4 times 4 times 4. And when we do that, we get a group of 3 here. And since this is cube root, we can take out 3. But 2 gets shot going out. The last 4 escapes. So you're left with 4. And then under the radical sign, you still have a 4. So you're left with 4 times the cube root of 4. And that is your answer. Okay? All right. Now, let's look at this particular problem. You'll notice that you have 30 squared in parentheses to the 1/3. So that really means this is 30 squared to the 1/3 power. Okay? So you're going to multiply the powers. Multiply the powers. So if we're going to do that, that means 2. And since we're multiplying fractions, let's put a denominator on it. 2 over 1 times 1 over 3. And then just multiply across. Easy peasy. So 2 times 1 is 2. 1 times 3 is 3. So we get the 2/3. So that means that this problem is changed to 30 to the 2/3. Now, we want to get this in simplest radical form. This is still in fractional exponent form. And so what we have to do is now convert this to a radical. And so this would convert into the radical. And remember that the denominator is the index, so that's cubed. And then 30 squared is what we're left with. Power is 2. All right? Now, like the previous problem over here, the question is, can we factor 30 and come up with some group of 3 that we can take out? Because remember, this is the index of 3. Well, 30 squared is 30 times 30, right? So this is the cube root of 30 times 30. And we know that we can break this up into, what is it, 10 times 3, or 2, let's see, 2 times 5 times 3, and 2 times 5 times 3. But you'll notice there are no groups of 3 in this. There's 2 2s, 2 5s, 2 3s. So we don't have the right combination. So you don't get 3 inside, so you can't simplify. So you can't simplify. All right, So the only thing you can do is multiply the 30 times 30 up, and so you're going to get 3 times the square root of 900. Since you can't get any groups of 3 things out, this is going to be the answer that you're going to have. That would be in its simplest radical form. All right, 27 to the 1/3. Now, it should be readily apparent that this would be the cube root of 27. And remember the 1 here, it's assumed to be right here. Okay? Now, you could factor this into 3 times 3 times 3. Okay? Cube root of 3 times 3 times 3. And you'll know, again, it's a group of 3. So all of them are going to try to escape. 2 of them are going to get shot. 1's going to make it. So here's the one that made it. So it's out here, and it's the answer. I'll put it in red since it's one of the escapees. All right? So this equals 3. Now I'm going to show you one other trick. Using your calculator, you could, if you wanted to, take and check to see if this is if there's a root that's going to come out of this, if it's going to simplify to a root, come out of the radical. Simply by taking your number, 27, so let's turn this on, clear it, 27, and then we're going to use your little caret button here to create an exponent. But instead of an exponent of 2 or 3 or 6 or something, we're going to use 1/3. So I'm going to put in parentheses 1 divided by 3, close the parentheses, hit enter, and you'll notice, what do I get? I get the answer 3. That's the root. Okay? Now that doesn't work for everything. So if we did 4 to the 4/3, you're going to end up with a remainder. Because remember we said there was a root, the 4 that came out, but you got a remainder of 4. So 1/4 stays in the radical. That's not a perfect square, and so you aren't going to get it when you try to type in 4 caret parentheses 4 divided by 3 close parentheses. Instead, you're going to get this long wonky number. Okay, so that's just an estimate. If you get this, you don't have perfect root coming out. But if you get something like we did here, where we took 27 in this case to the 1/3 power, hit enter, and we found out the root was 3. Nice shortcut. Okay. All right. Now this one is 8 to the 1/2 to the 3rd power. Okay. So we're going to remember here that this is really 3 over 1. Right? 3 over 1. So this is going to be the same as if we multiply this across 2 times 3. Oh, I'm sorry. This is 1/2. So this is 8 to the 1/2 times 3 over 1. Right? And I'll make this 8 bigger. So multiplying across, you get 8 to the 3 times 1 is 3 over 2, 3/2. Okay? And so that means, what do we get? 8 to the 3/2 is the same as, we'll put it down here, square root of 8 cubed. Right? Square root of 8 cubed. And that's, of course, going to be the same as we can factor out the 8 cubed into the square root of 8 times 8 times 8. And here, because we are using square roots, we can take out a pair. One poor 8 gets shot. 1 8 comes out. So you're left with 8 times the square root of 8. Now that looks like a good answer, but can you factor 8? Well, in fact you can. That factors into 4 times 2. So that equals 8 times the square root of 4 times 2, which is 2 times 2 times 2, right? Let's just write that as 2 times 2 times 2. Well, yeah, 2 times 2 times 2. All right, so we've got a pair of 2's here, and this is a square root, so we can take out a pair. 2 can escape. 1 gets shot. And so then we've got this 8 coming out over here that we had before. And then we get a 2 that makes it out. The other guy is shot. He's gone. So I now have 8 times 2 times the square root of 2. Right? And so this simplifies into 16 times the square root of 2. Okay. Now, if you were to take this and put it into a calculator, 8 to the 3/2. If we were to put that into a calculator, what would we get? Let's find out. So I'm going to take 8 to the 3/2. So 8 caret parentheses 3 divided by 2 in parentheses, and I get this 22.627417. But I want to use it as a check to see if this simplified answer down here is correct. So I'm going to type in 16 square root of 2. So I want 16 times the square root of 2. Close parentheses, hit enter, and look at that. I get the same exact answer. So that tells me that I simplified from here to here correctly. And I proved it with a calculator. So those are useful things that we can use going forward. All right. I think this is the last. Nope, got 2 more pages. All right, so we want to simplify, and we want to answer with positive exponents. Okay. So I'm looking at this, and I see I've got a negative exponent here. I've got a negative 9. So what do we do with those? Okay. So, all right, well, first of all, what we have to do is we have to, first of all, we have to finish writing in part of the problem. So this has an outside exponent of 5 over 3. So this is 125x to the 21, y to the negative 9, all to the 5/3 power. All right. So first of all, we have to look at everything and make sure we've got our exponents. So 125, it has an assumed exponent of 1. And then we have 21 and we have negative 9. Those are the 3 exponents that we've got inside. But we have to distribute this 5/3 to the 1 and to the 21 and to the negative 9. Okay, those 3. So if we do that, we've got 125. Let's use this. 125 to 1 times 5/3. That's 1 over 1 times 5/3, or just 1 times 5/3. And it's a little bit hard to see, so let's rewrite it. All right. And then I'm going to multiply that times x, and that's to the 21 times 5/3. And then I'm going to multiply it to the y times negative 9 to the 5/3. Okay? So I'm going to have to put a 1 under the 21 and a 1 under the negative 9, and I could even put a 1 under the 1. Well, 1 times 5/3 is just 5/3. So I'm left with 125 to the 5/3. times, now over here I've got x to the 21 over 1 times 5 over 3. Now you'll notice, if we can reduce, let's do that. And you can cross-reduce here. So I can cross-reduce, 3 goes into 21 7 times, and then into itself once. So I have x to the 7 times 5 or 35, and then the denominator is 1. So we'll leave it as 35. And then the y, I can also cross-reduce. Okay. And so I can reduce, and where was I here? Yeah, I can divide 3 out of both the negative 9 and the 3. So this leaves me with negative 3 over here, and this is 1. So negative 3 times 5 is negative 15 in the numerator. So negative 15. And then the denominator is 1, so I'll just leave that as negative 15. So now I'm going to take this 125 to the 5/3 and I'm going to turn it into a radical. Why? Because I want to make sure that I've got a number that is in simplified form, biggest simplified form. So I know that that's going to be the cubed root of 125 to the 5th. But you know what? That's kind of complicated to figure out the roots and all. Why don't I just take the 125, let's turn this on, 125, and then just let's do the caret and then parentheses, 5 divided by 3, close the parentheses. So that's what I had up here, right? And I'm going to see if it turns out to be something that comes out as a perfect square. I've got the root coming out. Now, it's not going to be a square because this is the 5th root, but I want to have a perfect root is what I'm trying to say. So let's find out. So let's hit enter. And I got 3125. So all I'm going to do is just bring this down here, and I used my calculator to figure out what the really is, 3,125. All right, and then I'll bring down the x to the 35 and the y to the negative 15. Now, what do I do with the negative? The negative, you just move it down. So I'm going to move this down. What do I mean by moving down? This is what I mean. I put 3,125 x to the 35 in the numerator of a fraction, and y to the 15 goes in the denominator. And notice the negative sign goes away. When you cross the border, going over jumping over the fraction symbol, you go from negative land to positive land. And similarly, if you have a negative in the denominator, you can have it jump the border and go into positive land and become positive. So that's a good answer. All right, now let's try this one. So this is 16 to the 1, remember, and we're going to distribute this 1/4 to the 1, the 20, and the negative 12. Okay? So that means I have 16 and to the 1 times 1/4 times x to the 20 times 1/4. So we'll put a little denominator on that one. And then times y to the negative 12 times 1/4. And we'll put a little denominator into the 12. All right. So 16, let's see, 1 times 1/4 is just 1/4. So that's 16 to the 1/4. And then let's see here. I've got The 4 goes into 20, so I can cross reduce. It goes into itself once, and it goes into 25 times. So I'm left with 20 to the 5th, or x to the 5th, I'm sorry. X to the 5th. And then over here, I can cross reduce again. I've got negative 12 and 4. The 4 divides into both. So this is 1, and this becomes negative 3. All right? So I end up with times y to the negative 3. And then what do? First of all, we want to take the 16 to the 1/4, and let's change this to radical. So it's a radical 16, and it's the fourth root of 16, right? Now we can simplify this, because isn't 16 2 times 2 times 2 times 2? So we exchange that for that's 16 for 2 times 2 times 2 times 2. We've got 4 2's. So again, since we're to the fourth root, we've got 4 of these that can all go out, but 3 of them get shot going out, and you're left with a 1 2 out there. So I got a 2, and then I have, let's bring down the x to the 5th, and the y to the negative 1/3. Negative 3. All right, and then we're going to move the y to the negative 3 down, so this becomes 2x to the 5th over y to the 3rd. And we now have our answer. Okay? All right, one more to go. One more slide. All right, so again, express this in simplest radical form. All right, so we've got 9x to the 6 to the 3/2 power. So that becomes, let's distribute, this is 1, remember? So we're going to distribute the 3/2 to the 1 and the 3/2 to the 6. So that means this becomes 9 to the 3/2. Because 1 times 3/2 is 3/2. And then, let's see, 6 times 3 is 18, divided by 2 is 9, or we could reduce. So this is x to the 9. All right? And 3/2, well, shoot. We could do the cube root of 9 again. Let me see. 9 to the 3/2. Well, let's just see what 9 to the 3/2 is. We'll find out if it's a perfect square. So 9, little caret, parentheses, 3 divided by 2, close the parentheses, 27. All right, it's 27. So since we now know that, now we can just rewrite this as 27. Nice shortcut, huh? And then we have x to the 9. Let's make the 9 a little smaller. Right? And that's your answer. All right? Your whole number is okay. Now, you're going to ask yourself, why is it, I've got 3 over 2 here. Wouldn't there be a remainder? Well, there would be, excepting, remember, 9 is 3 times 3. So that affects your answer. So always check this just to see if you end up with a whole number. If you get a whole number like 27 here, just put it down. It's your shortcut. Yeah, we could have done the radical. We could have, what is it? You remember the rule. You go back and you look at it, and so you're going to be looking at, again, just take back to the original sheet here. I can find it. 4. here we go. You know, we can go back and we can look at the original thing and we could say, oh yeah. This is the power is always the numerator. So we could look at our problem and we could say, all right, this is 9 cubed. So it's the square root of 9 cubed. And so using that information, you know, we could come back in and we could work out the radicals if we wanted to, but why waste the time? Let's do the last one. All right, so this is 4/3, and so we're going to distribute that again. Remember, this is 125 to the first, so we're going to distribute this to the 125 to the first and to the x to the 1, which is also 1, right? Well, that makes it easy for us. So that means we've got 125 to the 4 over 3 to the x to the 4 over 3. Well, okay, the 125 over 4 over 3, let's just test it and see, can we just take the 125, we don't have a variable in it, so we should be able to do this little simplification like we did before. So caret, parentheses, 4 divided by 3, see what we get. Aha, 625. So we can just go straight down to 625. Now, that doesn't work for this. You can't use calculator on variables like x. Okay, so what do we got to do with that? Well, let's just set it up the way we should. Remember, the 4 is the power, the 3 is the index, so this would be the cube root of x to the 4th, which is the same as 625 times the cube root of x times x times x times x. So we're just doing it the long way. We've got 3, a group of 3, 2 get shot, 1 escapes. So we end up with 625 times x, right? And then we're left with a cube root of x. Let me rewrite this. So it's 625x times the cube root of x. Okay. So I just wrote it twice because the little arrow was sort of hard to, it sort of obscured what we were doing. So you can use the shortcut when you have just numbers, and you know, it's got a number base, and you have a fractional exponent. Then you can try this calculator trick and get your answer simplified, so long as it gives you a whole number. If it gives you a decimal, it won't work. And then you have to use this method here, which works. It just, you have to, you know, spread everything out. You've got to cross out whatever it is that you don't have, or whatever it is that you have that's in the group that you're going to get rid of, and then you bring the one out, and if there's anything left inside the radical, you leave it inside. Okay, so that's it. That's it, ladies and gentlemen. I will let you go and have a wonderful day.